Today we're going to be talking about transformations. Our objective is that we will be able to use a transformational approach to recognize and graph a function given its equation. So below are the standard forms of each of our parent functions. So absolute value, we're going to see the lines. Quadratic, we'll see 2 as the exponent. Cubic, we'll see a little 3 as the exponent. Square root, we see the square root, and cube root, we'll see the cube root. Remember, that's got the little 3 here. So on each of them, it's got an a value right in front of the function. And then we have h and k. And I want to point out that in front of h and k are these minus signs. And what that's showing us, or telling us, is they are going to be the opposite of what they look like. Now h is always going to be inside the function, so under the square root, under the cube root, inside the parentheses for quadratic and cubic, or inside the lines for absolute value. K, on the other hand, is sometimes with the y, or sometimes it gets put on the other end after the function. So the thing to be careful with here is if k is with y, then it's opposite of how it looks. If k is on the end, on the right-hand side, it stays the same. Now a, h, and k each affect the graph in a different way. A is going to stretch and or flip over the x-axis. H moves the graph left or right. And K moves the graph up or down. So, to create these graphs, we're first going to identify which parent function we're using so we know which pattern to use. We're going to find h and k so that we know our new starting point, which I'll explain that in a moment, and we're going to use that starting point and a to graph the parent pattern. So looking at example number 1, because it has this little 3 up here, we know it's cubic. And our pattern for cubic was -2, -1, 0, 1, 2, -8, -1, 0, 1, 8. Since we don't see anything in front of our function right here, we know a is 1. It's just like we know this is a 1x or a 1y. We know there's a 1 there. H is the opposite of what's in the parentheses, so it's going to be 3. And since k is on the right-hand side, it's going to stay the same and be 1. So we are going to start at the coordinate 3, 1. So I'm going to go and I'm going to put a point at 3, 1. And I'm going to make a little star on it just to help us see what we're doing. So from that starting point, I'm going to use this pattern. So -2, -8. I'm going to go left 2 and down 8. Again, from this starting point, I'm going to go over 1 and down 1 for -1, -1. That starting point is the 0, 0 point. Then I'm going to go right 1 and up 1, and right 2, up 8. And then I'm going to connect them, and it should look similar to my cubic parent function. It's just shifted over 3 and up 1. In example number 2, this time we have a cube root function, and our pattern for that is -8, negative 1, 0, 1, 8, and -2, -1, 0, 1, 2. Again, a is going to be 1 because there's nothing in front of our function. H is the opposite of what's underneath. And since k is over with the y, it's going to be the opposite of what it looks like, so -2. So I'm going to start at 1, -2. Again, it's those two numbers. So 1, -2. I'm going to mark it with a little star so I can see where I'm at, and follow my cube root pattern. So -8, -2, back to my starting point, -1, -1, back to my starting point, 0, 0, starting point, 1, 1, and back to my starting point, over 8, up 2. And then I'm going to connect the dots to make it look like a cube root function. Because this function has the little 2 exponent, we know that this is a quadratic, which our pattern is -2, -1, 0, 1, 2, and our y's are 4, 1, 0, 1, 4. A, H, and K. This time we do have something in front of our parentheses. It's a 1/2, so that's our A value. H is the opposite of what's in the parentheses, so 3. And because K is on the end, it's going to stay the same and be -2. So I am going to start at 3, -2. Now, before I can graph my pattern, I need to deal with this A value. It's going to cut all my Y values in half. So from my starting point, I'm going to go -2, +2, -2, +2. I'm going to go -1, up a half a box, 0, 0, +1, up a half, and +2, up 2. Now I didn't fill in very much of my graph on this one, so I'm going to keep on thinking about how squares work and cutting them in half. So if I go over 3, 3 squared is 9, half of 9 is 4.5, so I'm going to go up 4.5. Since -3 squared and 3 squared are the same, I can just go on the other side and reflect that point. Now I still have lots of graph left. So I'm going to go over 4. 4 squared is 16, but I'm going to cut that in half because of A, and I'm going to go up 8. 5 squared is 25. Half of 25 is 12.5. I'm out of graph paper at that point, so I'm going to connect my dots and make my quadratic shape. And our final, there's two parts to it basically, but our final example. We're going to use this graph to answer example 5. So because I see the lines, I know this is an absolute value. Which has the pattern -1, -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. I'm going to find A, H, and K. A is the 2 out in front. H would be -1 because it's the opposite of what's inside. And since K is with Y, it's going to be the opposite of what it looks like, so 3. So I'm going to start at -1, 3. So I'm going to first use my A value to adjust my Y's. So I'm going to double all of them this time, multiplying them by 2. So from my starting point over 2 up 4, over 1 up 2, 0, 0, over 1 up 2, over 2 up 4. There is a little room in my graph paper, and if you look at the sides, they're making a pattern. Over 1 up 2, over 1 up 2, over 1 up 2 would be my next set, and absolute values are symmetrical, so I can reflect it on the other side. Now make sure your absolute values look like a V shape, not a U shape. So make those sides as straight as possible so it looks like an absolute value and not a quadratic. And finally, let's review domain, range, and end behavior. Domain, since there's an arrow on both sides, my domain will be -infinity to infinity. Range, the bottom of my graph is at +3 and it goes up forever, so my range would be 3 to infinity. And my end behavior, as x goes to +infinity, f of x goes to, and as x goes to -infinity, f of x goes to. And since both my arrows are pointing up, both my f of x's are going towards +infinity. That's all for today. Fill in your summary, and I'll see you in class.